Okay, so how is everyone today? Good, I hope. Looking forward to the weekend. We've got nice weather today. As I understand it, there'll be nice weather tomorrow and most of Sunday, but then the cold weather will be back Sunday evening. But it could change, I suppose. Any question before we get to business? Any questions? Okay, so last time we had just finished talking about intervals and interval notation and all of that kind of thing. And now we're in a new section. It is section 2.1, which is called rectangular coordinate system. Okay. So all of those intervals that we were dealing with were subsets of the reals. And the way that we denote the set of reals is with this fancy looking R. And then when you want to draw a copy of the reals, it is drawn as a horizontal line. This arrow on the right signifies the convention that the increasing direction is to the right. So if you were on the number line and taking measurements and moving to the right, then the measurements would be getting bigger all the time. If you were on the number line and taking measurements and moving to the left, the numbers would be getting smaller all the time. One of the points is so important that we'll mark it out for special naming. That's 0. So the value 0. And 0 is so important that it has multiple names, of course. Besides being 0, we also know it as the additive identity. But the other name that is relevant in this case is called origin. It's called origin because, well, in a sense, it's where everything begins. So if I said I want you to get to 3 on the number line, then, well, you'd start at 0, start at the origin, and then do what? You go right, 3 units. So it would be something like over here, you know. Suppose I asked you to find -4, then how would you do it? You start at the origin and go left a distance of 4. Terrific. All the numbers, the origin splits the real line into 2 pieces. The piece on the the piece on the right we'll refer to as the positive piece. All the numbers to the right of 0 are positive values. And the piece on the left we'll refer to as the negative piece. All of the values to the left of the origin have a negative value. So nothing really surprising here, I think. These are all things that we knew. Any question about these? So, since we had so much fun with the reals, what we're going to do is we're going to have twice as much fun now by using 2 copies of the reals. And we'll denote this as R2. It doesn't mean R times R in the same way that x squared means x times x, but sort of conceptually you could kind of think of it that way a little bit. What it means is that there's now two copies of the reals. We still have a horizontal copy, and it is still increasing to the right. And now we also have a vertical copy of the reals. And what is the increasing direction for the vertical copy of the reals? Up. It's up. So in the drawings that I draw, and also the ones I provide to you, the little arrow always indicates the increasing direction. So if I had drawn the arrowhead down here instead of up here, that would mean that it increases going down. However, you should know that it is essentially uniform in mathematics that for the reals, the increasing direction is to the right, and for r squared, the horizontal copy increases to the right and the vertical copy increases up. That's in math, but and usually the case in physics, but not always. However, in computer science, the convention is the opposite. The positive horizontal direction is to the right, and in computer science, the positive vertical direction is down. The reason for that, in the end, is because, well, several decades ago, someone had to invent a television. Does anyone remember who that was? Farnsworth. Invented television, and the way televisions work is they have the old style televisions. They don't even make this kind anymore. The cathode ray tube televisions. They've got a little electron gun inside of them, and the electron gun shoots electrons forward. A magnetic field deflects the electron. It goes forward to hit a phosphor screen, causes the phosphor there to be excited, and then emit a few photons. And the order in which those little regions that the gun strikes are called pixels. And the first one that the gun strikes is in the top left, and then the one immediately to the right of it, the one immediately to the right of it, the one immediately to the right of it, etc. It goes all the way across a row, and then the next one, it goes down one row, and then starts again. Blup, 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 blup. So the electron gun is going from top left, scanning to the right, it goes down one row, scans to the right, down one row, scans to the right. And because in time the electron gun is going down, that's why in the end, computer science, the increasing direction is down. So this is, well, at any rate, doesn't matter. You need to always ask if you're not clear what the convention is. Okay, these two copies of the reals meet at a right angle. And, well, for the real line, you could pick out a point and then perform a measurement and say, like, for example, I'm pointing at 3 right now. And conceptually, this line, I only drew this much of it, but do understand that this line extends infinitely far to the left and also to the right. Conceptually, what we're talking about here is a plane, a surface on which you could set things, like dishes and what have you. It extends infinitely far in all the directions. So here is a point that is on the plane. And just like points that are on the line, we give them a name. For example, that point is named 3. We want to be able to name this point. Okay, so the way that we're going to name it is as follows. So the horizontal axis, this is the first axis. And the vertical axis is the second axis. So to name this point, what we'll do is we will drop this point down to the first axis. And the way we're dropping it down is so that this is a right angle. And now that indicates a point on the first axis, and we can measure it on the first axis. Suppose we measure it and we determine that its value is A. Then we'll do exactly the same thing to the second axis. We'll drop the point over to the second axis so that that is a right angle. And suppose that, well, that's the measurement, and suppose we measure it to be B. So on the first axis, this point measures A, and on the second axis, this point measures B. So what's the name for this point? AB. A goes in the first position. Why does A go in the first position?
First axis.
because that's the measurement on the first axis. And B goes in the second position because that's the measurement on the second axis. Okay? One thing I'd like to point out that's unfortunate is that that is exactly the kind of notation that we use for intervals, for open intervals, and that's just unfortunate. However, the convention is so old, centuries now, it's not changing anytime soon, right? As a result, I try to never give an exercise where it could be confused. If I say, for example, 3,8, I try and always word the exercise where it couldn't possibly be confused between a point and an interval. But you're going to need to be on your guard for that. Any question about these things? So this coordinate system is referred to as a rectangular coordinate system because, well, every point is at the corner of a rectangle, which I hope for you raises the question of, well, are there other coordinate systems? And the answer is yes, there are other coordinate systems. However, we're not going to discuss them in this class. But for this coordinate system, the fundamental shape is, in a sense, a rectangle. There's other coordinate systems where the fundamental shape is a circle, more or less. And the name for that one is called a polar coordinate system. But we're not talking about that. Okay, so these axes are arranged in such a way that both of the axes have their 0 right there. So what's the coordinates of that point? 0, 0. And again, that point is referred to as the origin. All right. In the case of the line, the origin splits the line into two pieces. The piece on the left, which we refer to as the negative piece, and the piece on the right, which we refer to as the positive piece. In the case of the plane, the origin splits the space into 4 pieces. 1, 2, 3, 4 pieces. Their names are called quadrants, and they are numbered sequentially, starting in the top right, and historically it's always given with Roman numerals. So the top right one is quadrant 1, the top left quadrant 2, bottom left quadrant 3, and bottom right quadrant 4. Hard to believe that still using Roman numerals after all this time. Well, so I'm not so hot on memorizing the names of the quadrants. As far as I'm concerned, if ever I ask for the quadrant, you can call them 1, 2, 3, and 4 as written here, or if you could just say top right and bottom left and what have you, and this is fine too. Any question about these things so far? Okay, so here's a point on the plane. Suppose that it has coordinates CD. Now, because I haven't given you a scale, it is not possible for you to tell me the exact value of C and D. Like, it wouldn't be possible for you to tell me, for example, that D is equal to 10.8. You couldn't do that. But because of what is drawn, you should be able to tell me the sign of C and also the sign of D. So how about C? Is it negative or positive? C is negative. Why is C negative? Right. So C is the measurement on the first axis. So that means that because it's C, that means that this value right here is C on the first axis. And then the question becomes, is it to the left or is it to the right of the horizontal origin? Well, it's to the left. As a result, you know that C is a negative value. Similarly, how about D? D is a positive value because D is the second coordinate, so it's a measurement on the second axis, approximately right here. And then the question becomes, is it below or above the origin for the second axis? It's above. So this one is positive. So even though you can't tell me the exact value, because I didn't write a scale, you can still tell me the sign. Any question about these things? Finally, it is very, well, as we go on, we're going to end up dealing with situations where there's two variables involved. It could be something like the number of items purchased and cost, and they're related to each other. So that could be like, X and C, for X being the number of items and C being the cost. Or it could be, T and S for whatever. So when we're being purely abstract, like we're not talking about widgets and dollars, when we're just talking just in the abstract, very often the horizontal axis will be named X and the vertical axis will be named Y. But you need to understand that there's nothing intrinsically special about those names X and Y. They could be anything, right? We could do W and Z, we could do A and B, P and Q, whatever. Any question about this? Okay. So now, here's where I cheat, and I bring these. So all that I'm doing here is that I have a piece of paper that I'm taping now to the notes, but it looks nice. And for those of you that just feel compelled to do the same thing, if you go to where the course notes are, I have a PDF that has 6 of these on a page, and all that I do is I just print out a bunch of those pages and then copy these and then tape it. I'm not making any kind of requirement for you to do the same. I'm just saying if it seems to you you want to do the same, then fine. So here's a point. And I'm going to, for all the semester, consider these to be integer points. So on the horizontal axis, that's 1, 2, 3, 4, etc. And on the vertical axis, that's 1, 2, 3, 4, etc. So my question to y'all is, what are the coordinates of that point? 4, 3, right? So, and how is it that you figure that out?
4 points right on the left axis.
Uh-huh.
3 points up on the y-axis.
Okay, good. So, starting at the origin, because origin literally means where you begin, you move 4 in the first direction and 3 in the second direction. So the name for this point is 4, 3. Any question about that? Similarly, would you please tell me the coordinates of this point? 1, negative 5. Because starting at the origin, you need to move 1 in the first direction. And now, I agree entirely that we have to move 5 positions to get down to get here. But the thing is that notice that the increasing direction for the second axis, for the vertical axis, is up. So we're moving 5, but we're moving 5 in the opposite sense of the axis, right? This axis is pointing up, but we're moving in the downward sense. So that means that this one is negative 5. Any question about that? Okay, how about what are the coordinates of this point? 1 of these is right. Negative 3, 0, right? So, from the origin, because that's where you begin, how much in the first direction do you need to travel? 3, and in the opposite sense that it's pointing, right? So that means negative 3. So the first coordinate must be negative 3. And after you've moved negative 3 in the first direction, how far do you need to travel in the second direction? None, right? So 0. Any question about this? Okay, now that we've done that, now I'll turn the problem around and I'll say please plot, which means draw the points 2, 4, and how about 2, 0, and -5, or I wrote 4, so -4, -1.
From the origin, move 2 to the right,
Uh-huh.
and move up 4 from the origin.
Very good. So from the origin, 2 to the right and 4 up. So that's 2, 4. Right, correct. So now for this one, from the origin, 2 to the right, and then 0 up. And for the last one,
4 to the left.
-4 to the right, 4 to the left, and 1 down. Any question about these? This is okay? Okay. Good. So now we need to take a slight detour. So an equation, whoops, is 2 expressions with an equal sign in between. So no, so an equal sign between them. Probably no real surprises there. Some equations have variables in them, like x's and w's and things like that. But you could plug things in, like if there were some x's, you could say, well, I want you to plug in x is 7. And you could plug in 7s to all the things. So when an equation can be evaluated, so when an equation is evaluated, which is to say that there's no variables. It's all full of, numbers. And all expressions are defined because after all, well, you could have the equation could have 1 over x in it or something, and you could plug in x is 0, so you'd have 1 over 0, but that's not defined. So I'm talking about we've got an equation, we've plugged in values for all the variables, and furthermore all of the resulting expressions are defined. The equation evaluates to true or false. Okay. So now is where I have to say, brace yourselves. It's something that my experience tells me about half of you are going to find this uncomfortable. So, for example, How about this? 13 equal 13. Is that an equation? Yes. How about 13 equal 14? Is that an equation? Yes. Now, some of you are saying, I think some of you are probably offended that I've even written this, right? I can't believe that this is occurring. Is it an equation? It is. It is. Because after all, what's an equation?
Two expressions with equal sign.
Two expressions with an equal sign in between them. Well, that's an expression that evaluates to 13. That's an expression that evaluates to 13. And that's an equal sign. So this is an equation. Now, the thing that, for those of you who are a little bit uncomfortable, is I'm trying to separate two notions that my experience tells you many of you think that they're the same thing. So now we're going to separate them. Is this an equation? Yes. Is that an equation? Yes. What does this equation evaluate to?
True.
True. What does that equation evaluate to? False. That doesn't mean that this isn't an equation. It is an equation. It evaluates to false. That doesn't make it immoral or unethical. That's just what it is. So this is an equation which evaluates to true. And this one is an equation which evaluates to false. Okay. So how about let's consider the equation 3 times w minus 12 equal to 6. No, not 6. How about 9? 9 will do it. So, is this equation true or false?
We get a value. We have to evaluate.
Right. So my question is wrong. What was your question?
What does evaluate mean with the first two? How do you define evaluate?
To evaluate an equation is in the sense, so to avoid getting too mathematically technical, is just asking whether or not the thing on the left-hand side and the thing on the right-hand side really are equal to each other. So is it the case that 13 is really equal to 13? Yes. So true. Is it the case that 13 is equal to 14? That is not the case. So it evaluates to false. Then I wrote this equation down and asked, is this equation true or false? And then what's the correct response? Yeah, well, in a sense, it depends on what W you plug in, right? So the question itself is wrong. For me to write this equation and ask if this equation is true or false, that question is wrong. Okay, that would be like, well, it's just not a correct statement. So I could change it. I could change it to the following: is this equation true for W equal to 10? Well, how do we confirm or deny that?
Substitute the.
Yeah, we'll plug in 10. Okay. So 3 multiply 10 subtract 12 equal 9. Well, you know, you got to do a little bit of arithmetic to confirm or deny this. That'd be 30 minus 12. That's 18, right? So 18 equal 9. So what's the answer to the question?
False.
Right, so this equation is false, and therefore the answer to the question is no. No, the equation is not true when W is 10. Okay. How about, suppose I ask, for this equation, same equation, for which W is it true? For which W's, because there could conceivably be many, for which W's is the equation true? Well, we've even done it a little bit in our class, and your previous math classes you did it at least a little bit. The state of Texas assures me. So, well, we could perform a sequence of operations to isolate W. What could we do? Add 12, so that we have 3W is 21, and then divide by 3 so that W is 3. So W equal to 3 is the only W. 7, thank you. I'm not sure what my brain was. I don't know. I have no excuse. My brain was temporarily not present. So is the only W for which the equation is true. Okay. So that's a little bit clumsy language, right? For this equation, find all of the W's for which the equation is true. It's perfectly precise language, but it's a little clumsy. So let's give ourselves some convenient language. So given an equation in one variable, and I'm calling the variable x. But do know that there's nothing sacred about the name x, right? Here's an equation that has a variable, one variable, and the name of the variable is w. So given an equation in one variable x, the set of all x's for which the equation is true is called the solution. To the equation. Okay. So notably, a solution is an equation. So that is to say, for this equation, 3 times w subtract 12 equal 9. The solution is the set containing 7. That's it. 7 is the only element of the solution. Okay. How about now the beauty of this language here is that now I can simplify all of that, and I don't have to have that clumsy language, and I can just say, please solve w squared equal 9. So what I'm requesting for you is for you to report back to me all of the w's such that when you plug in that w, the resulting equation is true. And I just want you to just tell me the answer. Okay, good. You can 3 would work because 3 squares to 9, and negative 3 also squares to 9. Now, this is not the position in the course where we're going to go about the proper techniques for solving equations. I'm just putting one that's, I think, easy enough for you to just say, yeah, 3 and negative 3. Okay. How about, for example, please solve z squared equal negative 16. Yeah. No real solution. Now, why is that? Very good. You take any real that you can conceive. For example, take a positive real. If you square it, the result will be positive. And in particular, it won't be negative 16. Similarly, if you take a negative real and square it, well, the result will be positive, and in particular, it will not be negative 16. And if you square 0, you get 0, which isn't negative 16. So there's no solution. Okay. How about please solve 13y plus 18 is equal to 14y plus 11 minus y plus 7. So I want you to tell me all the y's so that the resulting equation is true. Okay, I think combining like terms is a good place to start. So the left side, on the left-hand side, the terms are already collected, but on the right-hand side, the terms are not yet collected. So I'll just copy the left-hand side. 13 times y plus 18 is equal to, well, I see 14 y's and then subtract 1 y. So we've got 13 y's. Then I see that we have 11 units and 7 more units, so that we have 18 units. And now we could, for example, subtract 13y from both sides. Supposing we subtract 13y from both sides, what's the new left-hand side? 18. And what would the new right-hand side be? 18. Okay. Now remember, 18 equal to 18, in what context did this come up in? It came up in the context of asking about the solution to this equation. I want to know all of the y's so that this is true. All of them, right? Is this true when y is 6? Yeah. Right? I'm asking, okay, concerning the numbers 18 and 18. Is it the case that when y is 6, that 18 is equal to 18?
Yes.
Yes. Is 18 equal to 18 when it's sunny outside? What about when it's raining? Yeah, all the time, right? All the time. So I'm just laboring this because many students get to here and then they kind of, I don't know, get stuck inside. The discussion is that for which y's for which y's is 18 equal to 18? And the answer is all of them. Okay, so then the solution is what? All reals. So I have given you several examples. So here's an equation, the very first equation that we wrote. Its solution contained exactly one element. The next one, I gave you an equation. Its solution contained exactly two elements, 3 and negative 3. The next one, its solution contained no elements. There were not any z's that resulted in this equation being true. And this example, the solution contained every real number. So the set of solutions can be wild and varied, right? You could say, can you give me one where there's 1,314 items in the solution? Sure I can. Okay, but that'd be too tedious to do. Next. So for example, I could say, let y equal 2 times x minus 1. So this equation is different than the previous examples because now there's two variables. There's two variables, and I could ask, is this equation true for xy equal to, how about 310? Well, how do we confirm or deny that? Well, we're going to substitute x equal 3 and y equal 10. If it's true. So then substituting x is 3 and y is 10, the resulting equation is 10 equal 2 multiply 3 subtract 1. Okay, the left-hand side is simple enough. The right-hand side can be simplified to 5. And, well, 10 equal to 5, is it an equation?
Is an equation.
What does it evaluate to?
False.
False. Is false. So what's the answer to the question?
Is not true.
Right, so the answer is no. Okay. Well, last remark before we get to the quiz. Given an equation in two variables, x and y, and do understand that there's nothing sacred about x and y. It could be variables a and b, p and q, whatever. Given an equation in two variables, the set of all xy for which the equation is true is called, now if it was going to be just like the definition that we wrote 2 pages ago, then I would write solution right here. It's called the solution. But for historical reasons, that's not what it's called. It's called the graph of the equation. I'd like to point something out that may be a little bit surprising. This is the definition of a graph. A graph is a set. And I'd like to note something that is not part of has nothing whatsoever to do with a graph, and that is that this definition contains nothing whatsoever about a picture. Okay, so then a graph is a set. Now, a picture of a graph is called a plot. So, it's easy to confuse these two terms because the most common case in college algebra where you're considering a graph is you're actually considering a picture of a graph, so what you're really considering is a plot. But then the author of the textbook, I'm sure, knows what a graph is because they have the correct definition of graph in the textbook. But then the author goes on to apparently be utterly confused about the distinction between graph and plot. So I encourage you to not get confused about it. Okay, so this is all the time we have for this. Please put away your things so we can have a quiz.